So welcome to this session about looking into how you use, in this case, transactional data in a bank on an enterprise level and actually in a fully production environment, low latency, and all the usual mumbo jumbo. But before we go into it, I just wanted to share, so like I do always before I have any kind of presentation like this for the public, I use the two best people in the world to determine whether the things and the messages I'm giving actually make sense. And these two individuals happens to be my daughters. They are 14 and 10. And if they can understand it, so can you, definitely. But of course, they have a slightly different view on these kind of things. So actually, in this case, I asked them, so what do you think of fraud? And any guesses as to what they said? The first question was, of course, what is fraud? So the older one, she is soon to get her own debit card. So I put it like this for her. I said, so imagine you have this card, right? And it is actually your wallet, right? It's directly linked to your bank account. It's actually money. So even though it's not a note or anything like that, it is money. So what happens if someone copies it or somehow looks at your number and maybe even picks off your PIN number and things like that? What happens? And actually the second question, and maybe most important, who is responsible? And what do you think she answered? She said, Dad, you work in a bank, it's your responsibility. You take care of it. It's your money anyways, but that's another thing. No, but the thing is, even if you ask in a general audience, the majority answer or the most popular answer would be that it is the responsibility of the bank to take care of my money. Even though you could say the card is in your hand, and it is, you could say, your responsibility to make sure that people do not steal it. And of course, in extreme cases, we can argue that it is actually your fault and things like that. But actually, we lose a substantial amount of money on this as a bank. Because in many, many cases, it's a loss. We don't get any money back. We don't have a father that helps out. So it is our responsibility. Right? So just a few notes on myself. I'm not going to go through it all. But again, I'm head of advanced analytics and architecture. The most important thing is I'm from IT. Hopefully you will not recognize that, because this is some of the barriers I'm trying to break down. I mean, this is a 20,000 plus people corporation, right? So we have silos en masse. Everywhere there's silos, and there are doors you need to knock on before you can talk to anyone. But this is, for me, bullshit, and pardon my language. I need to do this on a corporate level. If I succeed or my entire organization succeeds, at the end, who really cares? If we do not succeed as a corporate, nothing really is going to happen. So we're approximately 2,000 people in the IT organization and approximately 2,000 systems, so you can easily do the math. One system, one person. And the best thing is actually that when you join, we give you a welcoming gift, which is a system. So here you go. You have the responsibility of a legacy system. Congratulations. Awesome. So the agenda for today, I'm going to talk a bit about the journey. I'm going to talk a bit about the team composition. And you might even ask yourself, so why does he talk about the team? But we'll get back to that. Then I'll briefly introduce fraud and how we see it in Danske Bank. We'll talk about the new advanced analytics platform. We'll talk about some of the next steps, and at the end, we'll do some Q&A. Okay? So this is the team. These are the roles that are involved whenever we do a project. And this is actually not only, you could say, the fraud as such, but in pretty much everything we do. And it's data scientists. These are the new, someone called them gods, but that's maybe a bit too extreme. Others call them unicorns, but do unicorns really exist? But yeah. Anyways, data scientists, data engineers, platform engineers, I'm sure you all heard about these roles, and these are like the main thing. The way I see it, and we joke a bit around this, right? This is what we call the burger model. So the bottom bun, which is also the foundation, is the platform engineers. And why is that? That is because these are the guys who are building the infrastructure that the rest of the team can use. So you could say in the middle, which is the main burger, that's the data engineers. And the reason for that is these are the guys who are actually looking at getting all relevant data into play, doing data wrangling, cleansing the data, all these kind of things, so that the business and data scientists can actually start using it and harvesting that. The business, it's the top bun, because these are the guys actually, you could say, at the end of the day, responsible for the business product. These are the guys who are talking to FSAs and all these kind of people to make sure that this actually works in the larger context or in the real world. So you might be asking, what happened to the data scientists? Well, good answer. It's the crisp bacon. Because that's really the tastiest part, right? So yes, these are the bacon. And the reason for that is these are the guys who take all the data, take the capabilities from the infrastructure and put it to real good use. Of course, in full cooperation with the business. And actually, the business side of things might also have some data scientists. And this is why it's the burger model. It's incomplete if you don't have everything in it. And this is where I'm binary. Last week even, I told a head of a business unit, listen, if you want to do this project in May with us, you're going to join in. Your people, business analysts, data scientists, etc., they need to join the team, or I'm not going to do it. And of course, that's harsh language because ultimately I'm like a service provider thingy for the business. But I really don't care, to be honest. Because if we don't do it together, the chance of success is limited. And you all know what happens if you don't do these kind of things together. I'm pretty sure. You have seen where you get a list of requirements, you do your robotic work implementing it, then you bring back the product, and they're saying, well, this is actually not what we asked for. And then Steerco gets presented with this case, and people go mad, people chop each other's heads off, and whatnot, right? But if you do it together, you have shared responsibility. And the product that you're going to produce will certainly be a lot closer to the final expected product than if you do it disjointed. So these bacon guys, right? So how do they fit into this? And this is actually quite elaborate model, right? I'm not going to go through it all, but the 4 key elements is programming. Some people call it computer science. The statistical part, understanding the math and all that. The business, of course the business. You need to deliver business value. We don't do this for fun, right? And ultimately communication. And a lot of people ask me, why the communication? Is it because of the hot air? No, right? Imagine, and I'm certain you already have seen this, the companies who have been diving into this world. So when you do these type of things, a lot of people in the organization are a bit fuzzy. Okay, what actual capabilities are you bringing? What value are you giving to us? And when people start talking about machine learning or even deep learning, they start to fade away. So you need to be able to communicate it at a level that makes sense for the business counterparts, for the stakeholders, for the steercos, for other peers, everyone. It's very important to be able to do this. So this is our journey. And again, you could say the team is pretty much the same. We started off with, you could call it a learning phase, where we did lots of hackathons, proof of concepts, road shows, and this is actually the communication part, right? You need to convince people. Otherwise, you're not going to get funded. And without funding, you're not going to do anything. And the feedback loop is also very important. You continuously need to learn from what's going on. Gone are the days where you do all large-scale waterfall projects. You need fully agile projects, deliver on a monthly basis or whatever makes sense for you, continuous deliveries, and you feedback in what went very good, what should we keep. So this is the retrospective part. Feedback in what actually was a huge challenge and what did we mess up. Be honest. I mean, if I look at my organization, right, and in the 12, 13 years I've been there, we are extremely poor at recognizing projects that goes to hell. So we dump a lot of money, and it goes to hell, and everyone can see it. No one wants to acknowledge it. And then finally, at some point in time, someone is mature enough to say, okay, this needs to die. But usually, that only happens when you've spent 50, 100 million. I've even seen 150 million. So it's stupid, right? I think we can all agree. Coming back to this, partner up. Realize, be humble that you don't know everything in the world. Partner up with whatever makes sense. If it's Hortonworks, fine. If it's someone else, fine. Whatever makes sense for you. But realize you cannot carry the world on your shoulders alone. The second phase is the planning. Talk about business values. Look into reference architecture because, of course, you're going to build some infrastructure. And look at some proper use cases. And define your pilot projects. And please, for the love of God, always use this mantra. Fail, but fail fast. Realize that maybe in the initial stages, you will do 5 projects, pilot projects, and 3 or 4 of them will fail. No need to get worried. You can always cry later on. But realize that. That is key. And of course, at the end of the day, in the build phase, you need to build all the infrastructure part, the data science elements, how do you work in that environment, operating model, legal, and so on. I'll actually go to the next slide to talk a bit about the legal side of things. Because for us, it was very important to define what we called the ecosystem around big data. And again, many of these elements everyone can tell you. So technology, make sure that you continuously use the right technology, the right competencies, the right data, of course, the right exploration process, and so on. But the key for me is the benchmark down here. And it's actually continuous benchmark. You need to figure out how do you stay fully aligned with what's going on in the market. What are the new technology trends coming out? What are other trends coming out? Use cases, et cetera, et cetera. And it doesn't necessarily need to be from your own industry. You can easily learn from others. You can easily learn from others. And then the important part for us was the compliance and the legal and the governance. Because even with, you could say, the current legislation and what regulatory things that are on top of that, there will be many cases where you're allowed to do a certain project, but you should also ask yourselves, should you do that? From an ethics point of view. This is very important for us also due to, you could say, the Nordic market and the culture in the Nordics, because there we, as people, expect to be, any corporation to be fully transparent, open, what's going on, what do you do with my data, things like that. That is part of the culture. But I would say this is very important. And also, as you heard on the keynote earlier today, talk about ethics. Keep that in mind. You can do a lot of magical things, I tell you. Lots and lots of magical things. But always ask yourself, should you do that? Is it the right thing to do? So, a quick intro. If we look at, you could say, the fraud engine and the fraud detection setup that we have, this has been going on for ages. Of course, like any other banks, many industries, you guys also have systems which do something similar. And this one initially was built on what we call a rule-based engine. So a lot of what we call if then else. So if the amount is blah, and then you need to do blah. And it had minimal statistical capabilities. It had some, so it could cover a decent amount, but still not the best. So again, the detection rate was actually quite high, which is, of course, very good. But at the same time, it flagged a lot of transactions for, you could say, investigation afterwards. And a lot of these actually proved out to be false positives. So a transaction which were flagged, but actually did not have any fraud in them. It's very difficult to do an impact analysis in such a system, because imagine when you change one thing, how will it impact all the other if then else? If you don't have a proper impact system analysis or backtesting things in place, it's quite difficult. And ultimately, coming to the business side of things, which is the investigation unit, it gave them minimal control. So this is the system. It looks very simple, right? Of course, a lot of things are in, you could say, the red square. So talking about and detecting how, what kind of rules do we need? How do we detect fraud? And then the rest is actually just like a follow-up. I mean, again, if it's a straight-off transaction, no issues, no flagging, we just push it. If it's a bit fuzzy, then of course we mark it for investigation, and then the investigation process takes over. So how does it work? Of course, it requires an understanding of the domain. As we talked about earlier, it's a lot of these if-then-else rules. It's manually made. There are analysts sitting, looking at the data, looking at the market, and then coming up with these rules. And again, it's manually maintained in the sense that, of course, when the new rule is defined, it needs to be implemented in code, and then it's launched into production. So the pros of this approach, it's easy to understand, in the sense that each individual rule is easy to understand. It's if something, then something else. But you could argue, on the large scale of things, is it really easy to understand? Probably not. It's easy to explain. If, let's say, some authority are interested in what sort of rules do you have, we can explain it. We can just go through all the rules that we have. And it's easy to develop when you, again, look at the individual rule. On the con side of things, when you talk about complex situations and complex relation between different attributes or parameters, if you will, it's very difficult to show it in this setup. Very, very difficult. And of course, if you want some deep statistical elements or mathematical elements, it's also very difficult to implement. Again, there's a subjective inference of the rules in the sense that, I mean, it's a human being, right? He's sitting down based on his gut feeling and whatever, producing these rules. And there is a very long detection time in this as well. And ultimately, it requires manual maintenance. Someone needs to sit, monitor it, adjust the rules, adjust the thresholds, all these kind of things. Everything is manual. And of course, we wanted to do something about this. Why? As we talked about earlier, everything is going more and more digital. In the Nordics, especially in Denmark, you can actually buy a house without leaving your home or apartment or wherever you stay. It is now, you're now able to get a pre-approval for a certain amount based on your information. And if you find a house within that amount, you will get all the lease and the mortgage, et cetera, in your inbox. You can digitally sign it, and it's your property. End of story. No need to talk to anyone, nothing. And of course, that has an impact on this, right? Because the more you digitalize things, the more easy you make it, the more things you expose on the web, the more fraud you're gonna potentially get hit by. So that's why we wanted to do something different. So we started setting some goals together with a lot of stakeholders and others. So what do we need to do? So we wanted to develop a scalable and expandable platform using what we have defined as the Danske Bank blueprint of digitalization. So what's that? It's talking about taking an API approach, using open source technologies, using, you could say, the current standards within the marketplace. Making sure things are integratable, making sure things are easily expandable. You can move these solutions, for instance, either on your local area network or even out in our private cloud or ultimately in the public cloud. This is the kind of thing we were asked to build. 100% data-driven approach. And we'll talk a bit about that as well in a couple of slides. But again, don't rely on the gut feelings of people. It might be very good, that's fine, but we need to let the data do the talking. Use Hadoop, you could say, why do you have that as a goal? Mainly it's about not only using the right technology, but with the sheer amount of data you have here, we are talking 30 billion rows of data just for the initial step we took. Of course, you can get probably a Teradata cluster costing $500 million to do this, but in this technology, it's insanely cheap. So that's why we had that. We had a target about implementing a real-time solution that could score under 5,000 milliseconds. And yes, it is 5,000 milliseconds. And the reason for that is initially the kind of transactions we were looking into were transactions that were actually cleared during the night anyways. So we had actually plenty of time, but this was the target. And last but certainly not least, reduce the amount of false positive by at least 20 to 40%. So this is what we did. And everything is pretty much the same, except for the top right one. So the approach we took was we need to augment the existing setup. And this is actually quite important for you to understand. Because let me tell you, when we started this journey, I was probably the most hated person in core banking. Because everyone believed that I would take away their jobs, I would invent some new kind of machine learning thingy that would take over their lives and ultimately get them fired. That's what I had to work with. So my approach in this, and this is something we discussed way in the early days, that we augment what is already there. We develop something which is like an add-on to the existing system. So basically what we do is the machine learning setup we have, the deep learning setup that we have, provides insight, provides actually just a score, just a single value, as to how do we perceive this transaction that's coming in. What is our take on this? And then it's added to the existing loop. And then what you can do is you can talk about a confidence interval. So how confident are the global fraud investigation unit on this value? And based on that, you can take your decision. Fairly simple. So the data-driven approach, of course, you still need to understand the domain. You can't get around that. But I would argue that you actually don't need to understand all the intricate details of the domain. And this is another battle, but let's leave that for another day. Gathering and preparing the data, and this is sometimes a shocker for people, in the sense that we actually spent almost 80% of the time on this bullet alone. Gathering the data, cleansing the data, making sure it's right fitted to the models, all these kind of things. It takes ages, right? Unless you are a super organization where everything is governed, quality is perfect, you can walk into the data warehouse and you get hit by a super quality of data and you love it and God loves you and all that kind of thing. But in our world, it's like you walk into almost a toilet and you get nasty smells and all this kind of thing, and you need to cope with that, right? So that is what we do. Of course, what we wanted to do is automatically generate rules. That is like the core of machine learning, right? Adaptability, continuous adaptability. And of course, there's an element called retraining the model, and that is also something you need to do on a fairly continuous basis. The pros of this, it's automatic, it's data-driven, it's objective. It's objective. The data is doing the talking. There's no human intervention. And it has the ability to detect patterns in a very complex world. Figure out what type of parameters or features do you need to do this. And actually, I think it was in week 3, we found a feature that no one ever dreamed of using. But we could show with math that actually more than 10% statistical probability, this was actually an important feature to have. No one ever dreamed of it. Not even us. We were also amazed, but that's the case. Very fast detection of new patterns going on in the marketplace. As you guys know, Russian botnets and whatnot, attacking in a couple of minutes, but being hit by maybe billions and billions of transactions. So you need this adaptability. On the con side of things, it might be a bit unintuitive. People perceive it as like a black box. And this is actually also where you need to set in. You need to make it explain itself. And we actually use something called Lime. It's a framework and a capability to try to more understand and explain what features were triggered, what model was in place, why did this transaction get flagged, and so on. And data preparation is time-consuming. We already talked about that. Do not underestimate that. Please don't. Please don't. So coming back to the expert-driven approach, the gut feeling and all that, versus the data-driven approach. It looks similar, right? You need to do some data understanding. And one would argue that on the data-driven approach, you need to do it a lot more, both from the preparation point of view. But I mean, one of the guys in this unit, he said, okay, so why don't you just take the parameters that we use on a daily basis and just use that? And I said, but why? Let's throw everything we have in it. Why not let the machine decide what is the right feature or not? Why should we do it? So we added over 1,000 features to it. Fairly quickly it said, okay, you need these 25-ish. These are the ones that really makes sense. The rest is not really that important. On the pattern definition, this is the strong point, right? It's man versus machine. And again, we're not trying to take the job away or anything like that, because you still need to supervise this machine. But the machine is actually much better at crunching numbers and data than we are. That's the honest truth. And then you convert into rules or pattern recognition. That is also the difference, because again, simple if then else, and this is actually a fairly complex neural network that you build. And ultimately, of course, you still have the case handling. So let's talk about numbers. So the top one, you saw the goals earlier, right? Scalable, expandable. We did that. We basically said this is the spine of our architecture. This is what we need to do. So we did that. 100% data-driven approach. Yes, we threw all the data we could. These are just examples. We threw everything we had in it and let it decide what is relevant or not. We used Hadoop for the ingestion and enrichment of data wrangling, cleansing, all that was done there. And this platform can actually deliver a score in under 300 milliseconds. We're not there yet. Because if you deep dive into this figure, the model only takes 2 milliseconds. So 200 plus milliseconds is actually being used on different platforms talking to each other, protocols and whatnot. It's almost stupid, but we need to look into that and reduce that significantly. And the target we had with reducing false positives by 20 to 40%, 90%. And let me tell you, when I saw this the first day we launched, even myself, I was, no way, something is wrong. Go back and look at the figures again. And then we had like 4 people from the investigation unit, a couple of guys from payment systems, a couple of guys from the data science team. They sat down, they looked at the numbers, adjusted if anything needs to be adjusted and so on, and they came up with the same figure. 90% reduction. Actually, the figure as of Friday was 94%. It's amazing. It's amazing. And again, so let's say you don't have full confidence in this setup. Why not start with a confidence interval which is half of what we have shown here? Still, you reduce it by 45%. It's an amazing start. And again, remember, we are detecting the same things, but doing a lot better job. So this is awesome. So what did we learn? We actually went from a PowerPoint that I made and into production in 12 weeks. 8 sprints. Pretty fast. But remember, we had almost 50 people working on it. So it's a fairly large team, right? 50, 50. And again, all the initial disturbances we had, people thinking I was taking their job and all that kind of stuff, luckily we landed that pretty fast. So this was a thorough cross-collaboration effort. Information management, global fraud unit. We even had some external partners think big. They also participated in that. So we utilized everyone across the board. No point in saying, okay, this is your domain, let us do it. No, you come on in. Back to the team talk earlier we had, right? Everyone join in. Synergy, innovation across all systems. This is the augment add-on approach. It's the best way to get your foot in the door. Don't talk about replacement and so on initially. It's add-on. Let's build on your capabilities. Let's add something to your capabilities. From an inspirational point of view, so the blueprint sets a generic scene for combating these challenges. So we helped actually move this in the organization, which was awesome. The last one is the agile part. And again, take the agile approach. Don't even think about waterfall. Or if you do, never tell me. You have to do the agile approach here. You have to take that approach. Because again, with this technology, a lot of things can happen. And I'm being completely honest. It is open source. It is not necessarily fully enterprise ready. So you will stumble upon things from day to day. If you do the agile approach, you will hit them very fast. Then you can tackle them and try to get them out of the way. And we had a lot, I tell you. Looking ahead, so of course we are looking into improving the setup, reduce the scoring time as I talked about earlier, improving the data quality, adding more data, and also utilizing Spark for the heavy lifting of the data side of things. We're looking into new use cases, making sure all transactions are part of this, all countries, credit cards, mobile pay. It's actually a solution that we have for the Nordics, doing peer-to-peer transfer of funds, completely free of charge. Everyone can use it. You don't have to be a customer in Danske Bank. You can use it. And for this year, we are going to look into behavioral data, so doing behavioral analytics for the customers. So making sure that we are there when the customer needs us, And this can be in any sense, whether the customer is getting a new house, changing their cars, or on the more tougher side of things, getting divorced, having other life events that change their economy. So being there for the customer, that is what we want to do. And then continue our deep learning initiative, and last but certainly not least, the predictive maintenance. So talking about how do we do that on ATMs and others. But that's another case we can take. Questions? Just, yeah. Down here.
Would you share the presentation with everyone?
The presentation? Yeah, of course. It's actually already uploaded, I think. Sharing the presentation. We'll take care of that. It will be available.
And can you tell us a little bit about how you utilized the deep learning inside the banking system? Did you have it on-premise? Did you use the cloud solutions that already there?
No, we use everything on-prem. And the reason for that is this data is extremely sensitive. So it is on-prem solutions. And the reason we use deep learning is because in some of the use cases we talked about, regular machine learning is simply not good enough. You need a deeper level of the amount of features you're going to use, and you need the multi-layered approach. That is only way you get you could say, the target results that you are looking for.
Yeah. What was it? Was it TensorFlow?
Yes.
On GPUs?
Yes, NVIDIA cluster, yes.
Hi, great presentation, thank you.
Thank you.
You said something about using a tool to understand the decisions. Was it Line, I think you called it?
Lime.
Not one I've come across. Could you say a little bit more about how that works and what you can do with it?
So basically that's an approach or a framework, if you will, to try to dissect machine learning and make it more explainable, in the sense that what are the features that actually triggered this flagging, like the key, right? And also come up with an explanation in human readable format. That's also important. How do you actually interact with this?
That's really interesting, thank you. Because I think this is going to be more and more of an issue with deep learning, particularly if it involves personal data, which I'm sure you'll be moving on to.
Absolutely.
Because in GDPR, there's a right to understand why a decision was made, isn't it? So that could be really, really important.
Yes.
Yeah. Cool,
Yes.
thank you.
Yeah.
I'm.
Yeah. So apparently time is off, but if you want to have a chat, come on by. Let's have a chat.